Hello and welcome. So last week was a week of doing esports with some crazy functions and formulas. This week we're going to get a little bit back down to earth and do a little bit more classic financial modeling. So I'm going to be looking this week, so today, Wednesday and Friday, at the questions from ModelOff 2015 round 2. So today's question is about evaluating a performance contract. So you're a hypothetical contractor. You have a contract to provide ambulance services to a city for 5 years. You get paid a certain amount according to the number of calls you answer. If it goes over the expected amount of 20,000, then you get extra for each 100 calls over that. And calls are classified as emergency, urgent, or normal. And you've got, the key thing is you've got various different performance standards, so like service level agreements and penalties if you don't meet them. You don't get to abandon the contract if cash flows become negative. Fair enough. So I'm not quite sure why the performance deductions come first, but let's start here. So expected number of calls, you get 5,000 emergency calls in the first quarter. So we're building a quarterly model for 5 years, growing at 1.25% a quarter. Urgent calls, 6,000 in the first quarter, growing at 1%. Normal, 8,000, growing at 0.5%. There's lots of reminders in various different places not to round anything. Then the expected costs, so you lease ambulances for $80,000, starting off with 24 of them. You pay staff $25,000 a quarter, you start off with 96 of them, and the number of ambulances and staff is indexed to the number of calls. So whatever percent the number of calls goes up, the staff and ambulances go up as well, and we don't round that either. Other costs are $300,000 a quarter. And then we have the expected performance. So you expect 95% of emergency calls will have a response time within 7 minutes, 3% within 8 minutes, 1% within 9 minutes, 0.75% within 10 minutes, and 0.25% within 11 minutes. Urgent calls, you start off with 97% of calls being reached in the first 12 minutes, and that percentage falls by a quarter of a percentage point per quarter thereafter. And normal calls start off with an average response time of 16 minutes, and that increases by 2% per quarter. So then up here we have the penalties associated with that. So for emergency calls, it's supposed to take no more than 7 minutes. You get fined $500 for every minute that you're late, up to a maximum of $2,000, which is why the numbers don't go past 11-minute response time. So you should be targeting at least 95% of urgent calls being responded to within 12 minutes. And then if you go below 95%, then there's a penalty of $3,000 times whatever percentage you are below 95% times the number of urgent calls. And for normal calls, it's based on the average response time. So if it's less than 18 minutes, then you're good. If it's 18 to 20, you're fined $100 per normal call. If it's 20 to 22, 110. If it's 22 to 24, 130. And 24 and above, 150. I think I jumped around slightly out of order, but I think I've hit on everything there. Anyway, not sure why, but there was no workbook provided. You have to create your own. So I'm not going to make you watch me type a bunch of assumptions into a spreadsheet. So I've put one together. So we've got our model start date, term in years, our discounting rate. Oh, sorry, I skipped over that. But somewhere in here, yes, we discount at 10%. We're modeling on a real basis, so don't need to think about inflation. And when we're calculating the discount factor, treat each quarter as being exactly 0.25 years long. In other words, we are not using XNPV. So then, yeah, I've got my call volume here, my performance penalty details here. This one I've just turned into a lookup table. So, we're gonna find the next number below. So in other words, if we're at 16 minutes, it snaps down to 0. If we're at 19 minutes, it snaps down to 18. If we're at 1,000 minutes, it snaps down to 24. And then we read across to find the number. And then expected performance, got all the details here, and the expected cost. All right, so I think that's enough chit chat. I've got just a framework of a model set up. So this is this assumption number is our number of years times 4 to give me the number of quarters, plus 1 because I'm going to start from 0. So this is my Q0 just because I want to have that's where I'm discounting back to, and then the quarter end dates associated with that. All right, so let's start with the call volumes. Oh yeah, and I think I set up, oops, get rid of that. I think I set up right there. Okay. Don't quite know what's going on there, but this is the one I set up. I set up a named range called call types. Sorry, let me put that one over there. Call types. So in the first quarter, oh, and I've got my keystrokes over here, as you can see. I don't know, that might be too big, take up too much of the screen, be distracting. Feedback welcome. Anyway, so I'm just going to copy the formats there, and then this times 1 plus this lock, carry across, and then I always like to make, if my first column has a different formula from the rest of the row, I always like to make it red so I'm not tempted to accidentally copy across. Okay, so that's call volumes, and then I'm just going to add total at the bottom, B on HPP, and then I'm also going to add a call index, I'll call it, and that's just going to be what percent of the first period's calls do we have, because that's what I'm going to index ambulances and staff to. All right, so that's call volumes. Then I guess the next thing to do naturally is performance penalties. Then I'll use, make this whole column bold because that's where my headers are going to go, by call type. So let's look. The emergency calls. Oh, whoops. I left this already set up, which I didn't mean to do, but never mind. So the emergency calls, if you respond in 7 minutes, which you do 95% of the time, there's no penalty. Then there's $500 penalty for each minute after that, up to a cap of 2,000. So it is going to be, well, first ignore the cap. We'll just say number of minutes minus 7 log times 500 log. Copy that down. And actually, I guess the cap is already baked into the assumption here, the fact that you don't show anything after 11. So the cap, we don't even need the cap assumption here. So then the average per call is, if there's 95% chance of no penalty, 3% chance of $500 penalty, and so on, then the average penalty per call, sorry, is not going to be sum, but some product. Red flag here obviously is that this is greater than any of these, and it should obviously be somewhere in the middle of these because it's a weighted average of them. So $41, that's a much more plausible answer. So emergency calls is just, and I think that's the, that is the cost per call. Yeah, deduction per call of $500. Okay, so then it's just the number of emergency calls times that figure there. Let's just grab a nice number format and just fill it down a little bit here. And then we won't have to keep messing with that. Okay, so urgent calls. Urgent calls, oh yeah, it's based on how far off you are from 95%. So let's just first put in a helper column, or helper row here, which is going to be urgent call, what do we call this? I guess urgent call Z is what it's called in the description. So yeah, Z is defined each quarter as the percentage of urgent calls with a response time of no more than 12 minutes. And so we're told that Z starts off at 97% and shrinks by 0.25% per quarter thereafter. So I'm just going to say 97% minus 0.25% times this. Actually, times, wait, sorry, I need to subtract 1, so put it in brackets, times this, minus 1. And then I just want to get rid of the bit there. Okay, and then make that a percent. And there we go. So then my calculation is, if Z goes below 95%, then it's all this stuff. So say let Z be this, and we'll call it target be this, and penalty be this, and I guess I need the total number of calls as well, and that is G9. Then we're saying if Z is greater than or equal to the target, then no penalty, otherwise it's, what is it, the penalty, oops, sorry, back over here, it's the penalty times target minus Z times total number of calls. Close, close. No, we need to close more. All right. So we start off with no penalty, which makes sense because we start off at 97%. And then right here, we should start getting a penalty but we don't. Oh, sorry, that's because I have go away all the tipping. Sorry, so let's just change this to refer to the whole row, and then I don't have to worry about locking things in. Oh no, that still doesn't work. All right, never mind. Fine, I'll just lock my assumptions. Sometimes it's worth spending time diagnosing what's going on. Sometimes it's not. Okay, so now we see, yes, a penalty starts to appear when we go below 95%, and then it scales up, which is what you'd expect. Okay, so then normal calls, again, it's based on the average response time, and we're told the average response time starts off at 16 minutes and goes up by 2% a quarter. So normal call average response time, and that is going to be 16 times 1 plus 2% to the power of, again, I'm just going to use my quarter counter, minus 1. I'm also going to get rid of the sheet name here because I never like to have the sheet name showing. Okay, so we, all right, give me my number format. So we start off at 16, work our way up, that's fine. So then, how does it work for normal calls again? Down here. So it's according to the band you're in, gives you the number, so that's from the lookup table, and then we multiply that by the number of normal calls. Okay, so the number of normal calls times X lookup, the average response time in this table. So look up there, return from here to get the penalty, and we want exact match or next smaller item. So again, we start off with no penalty, which is fine until we get to 20. Until we get to 18. Then there starts being a penalty, and then we carry on across. Okay, so now we figured out our performance penalties. We'll just add in a total here. And copy across. Okay, so now I guess we need to figure out the other non-penalty costs, which is this stuff here. So just have a section expected costs. I'm going to say ambulances. Just first show the number and staff number, and then ambulance cost, staff cost, and other costs. So the number of ambulances starts off at this, or actually I'm going to use toCal, so I can grab both of these and just stack them one on top of the other. toCal that times, and we're going to multiply it by the call index. So times 100% first, and then we grow with the calling. So just like that. And then, sorry, wait. I took the cost instead of the initial number, so that should be pointing at 42, not 41. Okay, so there we go. That's looking a little better. Now we have 2 decimal places, happy days. And then we multiply this times, again, I'll toCal so that I can just stack them one on top of the other. And then the other costs are just a fixed amount per quarter, 300,000. Total cost. Okie doke. So then I guess we're going to get gross profit. So our revenue, we get 7 million plus for each 100 calls or part thereof that we go over 20,000, we get another 18,000. So I'm going to say let call. So you could do this as, here's your base revenue, here's your kind of extra calls revenue, and here's your total. I prefer to keep my models tight, but I also want to have some documentation, and the way that I like to balance that is by using a let. So I'm going to say let calls, or let's make it even more clear, let tot calls be this. Let base rev be this. Base calls be this. I'm sorry, I should be locking these as I go along. Then we'll say extra call unit is going to be this. and extra call rev can be this. Then our total rev will be base rev plus if total calls is greater than base calls, then total calls minus base calls. Oops. We're going to divide that by the extra call unit. So in other words, that's divided by 100, and then we need it's that or part thereof. So we're going to round that up to the next whole number. So round up that to 0 decimal places, and then multiply that by the extra call revenue. So in other words, for each, this is total calls minus base calls tells you how many calls you are over 20,000. Divide that by 100 tells you how many units you're over, and round that up to a whole number. Then you multiply that by the 18,000 for each one of those that you get. And that's it. And then we're just going to return total rev. And then, according to your preferences, you might prefer to sort of space this out. It's probably a simple enough one that I would be tempted maybe not to, but it's really just what feels reasonable to you and what the people you're working with will understand. So there's our lovely big formula. And what we should see is, yes, no, nothing until we get over 20,000. Yep, there we go, getting over 20,000 in Q4 17, and after that the revenue goes up. Okay, so then costs and penalties. So costs is going to be this, and let's put a minus sign on it. Fill across, and penalties is going to be from up here. And then gross profit. Okay. And then I guess we want our discount factor, which is going to start off as 1. And I'm just going to make that red because that's different. And then it's going to be this over 1 plus my discounting rate to the power of 1 over 4. So in other words, like it said, treat each quarter as equal. So we'll do 1/4 of the discounting. So then present value PV is just going to be some product of this with this, and let's number format that, and then I think we're ready to start answering some questions. Hopefully we'll get them right so we can make this quick. And if you don't want to watch me answering questions, I always put the sort of chapter markers down at the bottom of the video. There are some scenario ones at the end, so I'll be back to modeling after I answer questions if you want to skip and see that, or you can just stop watching. I really don't have any way to stop you doing that, even if I wanted to. All right, total number of calls made in the 3rd quarter of 2019. So 2019 here, Q3 is here, and total calls is there, 21425, which is F, good. 18 total revenue in the 1st quarter of 2020, excluding performance penalties. So that's this guy down here. In the 1st quarter of 2020, 7324, which is D. 19, what is the total cost for the 2018 year, excluding any performance deductions? So the sum of costs for 2018, 1, 2, 3, 4, those 4 quarters, 19944,614. Yes, that's B. Okay, question 20. What is the performance deduction due to emergency calls in the 1st quarter of 2016? So Q1 of 16 is back here. And penalty for emergency calls, 206,250, which is C. 21. Performance deduction due to urgent calls in the 4th quarter of 19. So urgent calls, Q4 19, 365,705. And that's E, good. 22. Performance deduction from normal calls over the whole contract. 13139,465. Yes, good. That's A. 23. With the net present value of the contract. Here. So 18707,961. Yes! It's always nice when things work. Okay. Considering a new preventative healthcare initiative that means no growth in total call volumes over the next 5 years for an additional fixed quarterly cost of $100,000 to achieve, what is the net present financial benefit or cost of this initiative? Okay. And I think the last one's a scenario question as well. So I'm just going to add a new section here. Which I will call scenarios. So say Q24 sen, whoops. And that is going to be, I'll switch it to false because I want it to be off by default, and I'll set up another one here for Q25 sen. And let's just give those names for ease of reference. Oops, what am I doing? Alt F3. Q24 sen and Q25 sen. All right, so what do these things impact? No growth in calls and additional quarterly costs of 100,000. Right, so other base, other Q24 sen. Oops. So the base is 300. The flex is to add another 100, and then we'll just say here if Q24 sen, then give me the scenario number, otherwise give me the base number, and you'll see that stays as 300,000. Okay, and then the growth rates similarly. Why is my mouse behaving funny? Here we go. Growth, base, growth, Q24 scenario. Not SNI sen. Okay, so this is the base, this is the scenario, and then same again, we'll say if Q24 sen, then give me the scenario numbers, otherwise give me the base numbers. So the important thing is I'm kind of setting it up so that the cells that are already driving the model are going to kind of continue being the ones to refer to. So I don't want to, set up a new scenario here and then say sometimes point to this and sometimes point to this. It's easier to just have an active one here and a switch here to determine which one it's pointing to, and then everything else in the model stays the same. So that's question 24. So then I want the PV. I think the question was how much the PV, net present financial benefit or cost of the initiative. So we just want to know the PV with and without the initiative. So that's true, false, and the difference will be the benefit. So data table, column input cell is that. So if we do this thing, then we say we increase the financial value by 2,996,977. Hooray! So that is E. And then question 25. So we turn those changes back off, which is fine because I've just left the scenarios as false. You can reduce the total cost of deductions each quarter by 50% if you increase the initial number of ambulances by 25% and the initial number of staff by 25%. Okay, so we'll just do a similar thing here. So we'll say initial number base, initial number Q25 sen. So these are going to be this times 1.25. Just copy value paste. And then this is going to be if if Q25 sen, then give me the scenario numbers, otherwise give me the base numbers. And then we're going to have to do a penalty factor. Penalty factor, which is going to be 50%. So we'll come up here. I'll shrink my formula bar now that I'm not looking at my enormous formula. So here we'll say penalty factor, and we'll say if Q25 sen, then give me that 50% block, otherwise 1. Very across, make a percent, and we just need to multiply each one of these by that. Copy across, and multiply this one by that, and copy across. Okay. And we've already done the other bit. Okay. So then, same idea. I'm going to point this to the PV, which is there. And say, what do we like with it? What do we like without it? What's the benefit? So DT for a data table. Column input cell is this. And woo, that one's terrible. Lose loads of money if you do that plan. So don't do that plan. So 10, 604, 521. That is good. Okay, so that's D. And then quick check. FDBCE, FDBCE, AAED, AAED. Cool. All right, I will be back on Wednesday with the next one. Thanks for watching. See you next time.